Algorithm subject, short notes. Small doubt also there, you can ask me. Right? See the straight max mean. See the straight max mean. Right? So if you want to find out maximum element, minimum element in the given array, right? Divide and conquer. We are starting the topic. Right? In the algorithm subject, short notes, divide and conquer is the starting one. Right? Straight max mean. So finding maximum minimum. So I think you will take one for loop. You will take one for loop. In that for loop, you will find out the maximum element, minimum element, one loop required. So to find out maximum minimum, right, using straight maximum, time complexity order of n. Because of only for loop is there, na, space complexity 1. Right? If you see the number of comparisons to find out maximum minimum using straight maximum, best case n-1 comparisons. Worst case 2 into n-1, average case 3 by 2 into n-1. Right? Straight max min. Right? Topic is divide and conquer. In that first topic is finding maximum minimum. Finding maximum minimum. We are doing straight maximum minimum. Straightly finding maximum minimum. So these are the things everyone know this. If you apply the divide and conquer to find out maximum minimum, if you apply divide and conquer to find out maximum minimum, right? I think there also same story should be done. To find out maximum minimum, you have to do one scan. Time complexity order of n. So you will divide like this, two parts. You will divide two parts like this. Right? You will keep on divide like this. Afterwards, you will start combining. So if you see the total story, time complexity order of n. Because if you done like this, I think stack size log n. Divide and conquer means by 2 by 2 by 2. So log n stack space. Next one, number of comparisons needed for finding maximum minimum using divide and conquer is going to be every time 3 by 2 into n minus 2. Right? Some recurrence relation will come. So this is the recurrence relation. Tn is equal to time complexity recurrence relation. Tn is equal to 2t n by 2 plus c. If you solve this one, you will get the time complexity order of n. Right? Because of by 2 stack space is log n. And if you see the comparisons, 2t n by 2 plus 1, right? I think to find out maximum minimum, right? So I think let's see one small line, right? Everywhere, if to find out maximum minimum, you have to do two comparisons. Exact comparison for between the two maximum, one comparison, between two minimum, one comparison, plus 2. So if you solve this one, finally you will get this one. At most probably everyone. So finding maximum minimum with divide and conquer, without divide and conquer, we done. Right? So please take care. So comparisons are always, right? With divide and conquer, comparisons are always 3 by 2 n minus 2. Right? Perfect. Now let's go to power of an element. Right? So this is, right, using divide and conquer. If you see power of an element, a power n you want to do. So what you do is a power n by 2 into a power n by 2 using divide and conquer. But because of these two are same, you no need to do this. First get this, then do one multiplication. So you are doing half only. So Tn is equal to Tn by 2 plus one multiplication, which will take constant. So this is the recurrence relation for time complexity. So time complexity, if you solve it using master theorem, log n you will get. Number of multiplications are, I think every time one multiplication you are doing plus 1. Right? So I think when you solve this one, you will get approximately log n multiplications you will get. Every time one multiplication like that log n. That is the power of an element. Everyone know. If anyone don't know, please be careful. I am not saying anything new here. Please be careful. I am not saying anything new here. Please be careful. Now see the binary search algorithm. Right? See the binary search algorithm. Binary search will be applied only on sorted array. Everyone know this. Indirectly, directly, binary search will be applicable on sorted array. Indirectly, directly, binary search will be applied on sorted array. Right? Next one. What is it okay? Is there any issue? Please let me know. Let me know if any issue. Can we go further? Can we go further? Can we go further? Can we go to binary search? Hello, can we go to binary search? Yeah, let's start now. Binary search algorithm, right? Binary search algorithm, it is applicable only on sorted array. Binary search is possible only on sorted array, directly or indirectly. Okay, next one. What are the binary search time complexity? If you lucky, middle itself, you will get the element. Middle itself, best case is 1. What is the worst case? Again by 2, again by 2, by 2, by 2, by 2, by 2. Worst case log n. Worst case and average. Let me write now. It is the best case. It is a worst case, average case. Right? What is the space complexity? I think if you lucky, starting itself, you will stop. Best case 1. Worst case, average case is, right, log n. Okay, fine. Space complexity. If you go to non-recursive program, best case is 1. Worst case and average case becomes, right, log n. Worst case and average case. Best case is 1. That is okay. But when you say non-recursion, space complexity will differ. Space complexity every case. Space complexity every case. Every case becomes order of 1. Space complexity every case becomes order of 1. Everyone know this. So I'm not able to say anything here, just other than main points writing. I'm not doing anything here. Just I'm writing the main points. I am writing the main points. Try to understand. I am not doing anything here. Just I am writing the main points. Now, can you see some problems here? Can you see some problems here? Just I am writing the main points. I am not doing anything else. So can you see this one? An array of n elements in which until some position all integers, until some position all are integers, and afterwards dollars are there. So there is one array, n elements are there, until some position all are integers. Let us enter until this place all are integers are there, integers. And afterwards there are dollars. Afterwards there are dollars. Okay, fine. Assume array of size, assume array size is unknown. Array of size is unknown, and after array all are dollar symbol, right? All are, right? I think some end operators. Array size, array having size, but we don't know that size. We don't know where is the last element. But one thing I can easily say, after your array, there are end operators. Right? Until some position in this array, integers are there, afterwards dollars are there. Whenever array is over, right, all elements are going to be in the memory ampersand operators. Right? Or end operator, some operator. Right? Now he's asking, find the position of first dollar. Find the position of first dollar. I think this one we have to find out. The similar kind of problems, many things we done in the classroom. We done in the classroom similar kind of problems, many, right? Can I apply binary search or not, right? Just remember, array directly not sorted, but indirectly sorted. Array directly not sorted, but indirectly sorted. Try to understand. This is indirectly sorted. Array indirectly sorted. Please be careful. Okay, I think you can apply binary search. Linear search you can apply like this, asking every person until here. Worst case end time. But when you see binary search, you just find out mid element. You may say that, sir, how to find out mid element? I don't know last element position. How can I find out mid element? Yeah, exactly, that is the question here. Right? The exact question here is that only. Mid element you cannot find out. How then? So ask the first person, are you dollar or not? No. Then ask the second person. First person, no. Then double it. Second person, are you dollar? No. Next ask the fourth person, are you double? No. Next ask the eighth person, are you double? Sorry, are you, right? Are you dollar? No. Ask the 16th person, are you dollar? No. Right? Next ask 32 person, are you dollar? Yes. But I want the first dollar. So when you get the 32 person is dollar, ask before also dollar? Yes. Then you have to apply left side. Right? Between these two people, you have to apply. So like that, I think now you got almost array size you got. From now onwards, a normal story. So I think you can apply. So log in, find array size. So you got almost array size. You almost got array size indirectly, directly. Log in time is completed. Now on that you can do normal binary search story. Right? So find the array size, which is log in, and apply binary search one more log in. Total becomes log in time complexity. Log in plus log in, 2 log in, which is nothing but log in. Right, fine. See the one more problem. An array of n integers, find any two elements a and b such that a plus b is greater than 1000. Remember, an array of n integers, find any two elements a and b such that a plus b is greater than 1000. So is not mentioned, is it sorted or unsorted? Is not mentioned, so anything can happen. Let us assume that unsorted. Let us assume that unsorted. So what you do is, you have to find two people such that their sum is greater than 1000. So what you do is, right, I think in this array, first person will ask every person, our sum is greater than 1000 or not. At anywhere match is there, stop it. Match not there, match not there. Continue, right, with the second element. Same story, continue. I think n times linear search, n square. That is one way. So if you want to apply binary search, first sort, which will take n log n. So after sorting, I think if it is a sorting, two element sum is, you want greater than 1000. I think last two people is answer. First to sort, return last two elements, which is n log n. There is no need to apply binary search also. Binary search purpose I tried, but there is no need to apply to binary search also. Right? Next one, right? That is a one idea. So comparing first one, n log n is better. Can you see the third one? Can you see the third one? Find max 1, max 2 in unsorted array. I think using the find max min algorithm, right? Find out the first maximum, second maximum. Scan one time, one maximum. Scan one more time, two maximum. Answer is two maximums. Otherwise, two passes of bubble sort apply. I think 2n time complex to order of n. So for this problem, answer is order of n. I want to apply binary search, I think, right? So, but the problem is array unsorted. Unsorted, you have to sort. After sorting means n log n is over. Comparing n log n is better. So third one is the answer for this. I want to give you examples also I am giving now. Next one, an array of n integers, output find any two elements a and b such that a plus b is less than 1000. Less than 1000. I think I want a sum of two people, right, whose sum is going to be less than 1000. I think two minimum people. Two minimum. So you can apply all algorithms, whatever we done, but one more best idea is find the first minimum, second minimum, right? So which is nothing but a selections are two passes, which is nothing but order of n. I hope you people are getting. Those people who are watching, please can you comment? Can you please comment, right, in the comment section, right? How is going on? Are you able to get or not? Can you check? Please comment in the comment section. Everyone, please try. Not only coming, yaar. Not only coming, please comment in the comment section, yaar. What is this? You are sitting idle. Just coming and sitting idle. Just coming and sitting idle. What is this, yaar? Please, why don't you ask something? Why don't you comment something? Why don't you? What is the purpose of coming then? Why I am teaching? Why are you listening? Why I am teaching? Why are you listening? If you don't want to ask, then why you came here? Please, can you comment in the comment section? Make it fast. Bro, make it fast. Rajkumar, make it fast, yaar. Shreyas, Sneha, everyone, please comment in the comment section. Are you getting? So some problems of binary search is going on. Some problems of binary search is going on. So, right, finding max min we done. Power of an element we done. Binary search some problems I done. Binary search some problems I done. Let's go to one more problem of binary search. So, in sorted array of n integers, output find any two elements a and b such that a plus b is exactly equal to 1000. A plus b is exactly 1000. Not less than, not more. If it is less than, after sorting first two people, which is nothing but two minimum, it's greater than, I think two maximum. After sorting last two people, or directly find out two maximums. Right now, exactly two people, exactly two. I want two people whose sum is exactly 1000, not more, not less. Then I think using n times linear search you can apply. Right, first person will ask all the people, anyone is there who's right, both of our sum is 1000, like that n time linear search. Okay, n times binary search also you can do because it is sorted. So that is a n log n. Comparing n square, n log n better. Now one more thing is going to be greedy technique. So here take one pointer, here take one variable or one pointer, whatever. You add both of them. If sum is 1000, stop it. If at all, it is less. Right, smaller person increase. Right, if at all more, bigger person decrease. So like that it is going on. This is called two pointers technique, which is I think one scan, which is order of n. It's almost like one scan, which is order of n. So these are the problems. Binary search algorithm, everything I kept here. Binary search algorithm, everything I kept. Everything, even problems also I kept. Even problems also I kept. Non-recursive program. Best case 1 time, worst case log n time, average also log n. Non-recursion. Non-recursion, same, space complexity becomes 1. Other than this, nothing. Problems also I done. Mostly you can expect this one in the exam. Mostly you can expect this one in the exam. Someone is saying PDF milega, of course. Right? I will give that. I will give that. Right? PDF also will come, so don't worry. Now next one, I think whenever I think binary search is over, now let's go to merge sort. Careful about the merge sort. Everyone be careful about the merge sort. Merging two sorted subarrays is known as merge sort. Merging two sorted subarrays is known as merge sort. Okay. So recurrence relation, I think you will divide into two parts like this, right? When you are combining every time n time, when you are combining every time n time. So I think it's going to be 2tn by 2 plus n. So if you solve this one using master theorem or substitution method or recursive tree method n log n, space complexity, if you observe, actually for stack only log n. But while doing merging, you will take an extra array, which is order of n. So log n plus n, which is going to be n. And one more thing is, it is a stable algorithm. But the problem is, it is taking more than log n space. It is outplace algorithm. Right? Used when stability is required. Whenever stability matters, you need stability. Right? You can go for merge sort. Stability matters. Go for the merge sort. Right? Next one. So can you see some problems on this? See some problems on this. Log n sorted subarrays, each of size n by log n. Find single sorted array with all elements. Right? This problem already we discussed in the classroom. Right? I will show to you also same. Right? Log n sorted subarrays, each of size n by log n. You want single sorted array. So each of size n by log n. See, each of size n by log n. Yes. If you add them 2n by log n. Right? So if you see in this level n by 2, right? Log n by 2 people are there. Every one size is 2n by log n. If you cancel it, n came. So in the next level also, if you observe, here also n will come. Here also n will come. Here also n will come. Here also n. How many levels are there? You are dividing. I think here log n people. You are dividing log n by 2 by 2 by 2 by 2. So if you divide anything by 2 by 2 by 2, log of whatever is there, it will become log of log n. So log of log n level, every level is n cos. So every level is n cos. Number of levels are log n. So final time complexity n log n. Someone is saying hello, sir. Hi, hello. Yeah, I think this problem already we done in the classroom. In the classroom, it is already there. Just see, the purpose of short notes is remaining one time. Main points covering one time. Main points covering one time. Other than this, this is the purpose of short notes. Main points covering one time. Right? Input. A sorted subarrays, each of size n by b. Find single sorted array with all elements. A sorted subarrays, each of size n by b. Find single sorted array with all elements. Right? If you observe clearly, A sorted subarrays. A people, na? In the next level, A by 2 people. Next level, A by 4 people. Okay? Right. Now, what is the first level cost if you observe? A by 2 people are there, each of size 2n by b. 2 cancel. Right? It is going to be check properly. I think what is the answer? A_n by b. Verify properly. A_n by b. Every level cost is A_n by b. How many levels are there? I think bottom level A people are there, na? A groups are there. Right? You are dividing by 2 by 2 by 2. So log A. So log A levels. Log A level, every level is A_n by b. So answer is going to be A_n by b into log A. That's the answer for this. This is the final time complexity. Final time complexity is this. Final time complexity is this. I think everyone is fine. Make sure this problem already we done many times. We done in the classroom many times. A sorted subarray. Let's see this one. A sorted subarrays, each of size n by b. Remember, A sorted subarrays, you are dividing by 2 by 2. So log A levels will come. Right? Next one. Total how many? A sorted subarrays, each of size n by b, na? Which will goes to A n by b. So every level A_n by b, because total elements are coming from one level to next level. So every level A_n by b people are there, right? I think number of levels are log A_n by b into log A. So that is the time complexity. Let's see one more problem. N by A subarrays, each of size C. N by A subarrays, each of size n by b. So total elements are n squared by AB people. And one more thing is subarrays, each of size n by b. See, remember, it is not sorted subarrays. N by a subarrays, but if you want to apply merge algorithm, you have to sort first. In the previous problem, if you want, you can verify also sorted. Before that also, if you want to apply merge algorithm, you have to, you should have sorted. But unfortunately, in the third problem, there is no sorted. So n by a subarrays, each of size n by b. So total elements are n square by ab, okay. But n by a subarrays, each of size n by b, right? And next one, each of size n by b, do sorting using bubble sort, right? Find single sorted array with all elements. So you want to say that each subarray is sorted using bubble sort. What is the bubble sort? Worst case, right? N elements n square time n by b elements n by b whole square, right? N by b whole square. So at the first level, if you observe the first level, so how many people, right? Each group size is n by b. If you do the whole square, n square by b square, n square by b square, right? Be careful, right? Every one sorting will take n square by b square time. Okay, that's fine. So, but how many people are there in this group, right? How many people are there in this group? N by a people. So it will goes to n square by b square into n by a. N by a. Verify if anything is missing. If anything is missing, please verify. Right, first level cost. I am talking about first level. Same thing. First level, every person using bubble sort. What is the bubble sort time? N elements n square time. N by b element n by b whole square time. But how many groups are there in the first level? N by a groups. Multiply. So totally this much. This is the first level cost. Second level onwards, I think normal. N by b, 2n by b, 2n by b. How many people? Whatever is there in the below level, how many levels are below? How many people are there? N by a by 2. N by a by 2 becomes n by 2a into 2n by b. If you do n square by ab, it's a normal story. N square by ab, every level cost, number of levels are log n by a, right? Same story. Please check one time. I am not doing anything new. Short notes mean just reading only. Try to understand. Some people are asking, sir, why he is reading? Why this person is reading? Then what is the meaning of short notes, Bhaiya? Short notes means other than reading what? Actually, I don't want to take also. But everyone is dying on the right, social media. Mahamardhan, right? Right, this one, that one, right? Maha revision, right? They are doing hangama. Other than this, nothing there, right? Actually, there is no requirement of all these things. So the purpose of short notes is what important thing I can keep here. What are the important things I can keep here? Just I written the important things. I am keep on reading. Just I am explaining little bit. If anyone is not clear, you can ask me. Sir, it is not clear. You can ask me, right? You can ask me. I will reply. The purpose of the short notes is, sir, what are the things you will keep in the short notes? These are the things. These are the things I kept in the short notes, right? So I think you should know about merge sort. Can you see this one? You should know about merge sort, right? Right? If you should know about merge sort, what is the merge sort? Recurrence relation for a time complexity. What is the time complexity? What is the space complexity? Right? Next one, is it stable or not? Is it in place or not? And some problems on that. Okay, I done few problems. Let's go to quick sort. See the quick sort, right? It is in place algorithm. Quick sort is in place within the array. It don't take extra, right? More than log n, it don't take. If anyone taking more than log n, it is not in place. It is in place because it is not taking more than log n. Next one, it is unstable, right? Whenever repeated elements are there, sometimes order is changing. So it is the first 10, it is the second 10. Whenever you are doing a quick sort algorithm, sometimes positions will swap. Unnecessarily repeated people, you are swapping. Unnecessarily repeated elements, you are swapping. So quick sort is not stable. That's okay. Next one, right? So quicksort algorithm major story is a partition. Partition algorithm one for loop. So time complexity order of n every case. Right? Next one. That is the partition algorithm time complexity. Let's see the overall time complexity of quicksort. Overall time complexity of the quicksort you see, right? Worst case n square. Best case and average case is let me write. Best case and average case is n log n. Right? When array is already sorted or almost sorted, quicksort will give worst case time complexity n square. Everyone know. What about space complexity? What about quicksort space complexity? It is also divide and conquer, right? If you divide in the best partition, if you divide in the best way, right? So I think then at the time what happened is best way if you divide, log n will come. Worst way if you divide n, but there is a one algorithm, balanced algorithm is there, almost like using recursion, right? Using recursion, non-recursion combined. Normal algorithm, na, both the side you will do recursion. But there is a one modified algorithm, best way of, efficient way of writing the quicksort algorithm. If you apply that model, what happened is worst case log n space will come. Worst case log n space, average also log n, right? Best case is 1 only. So best case is 1 stack space, right? Using the best algorithm. If you write the quicksort best way, right? If you write the best way, space you can save a little bit. So best case is 1, worst case average case log n. That is the reason quicksort is in place, right? So if you write the blind algorithm, both the side recursion, if you do, that algorithm will take worst case n space. If worst case n space taking, this is also become outplace algorithm, but it is in place. Why? Best algorithm if you write. Time complexity will be same, there is no change in that. Space complexity, best case becomes 1, worst case average becomes 1, log n, right? Be careful. So quicksort, some problems also, whatever there in the classroom, right? Some problems I written here. Quicksort, right? Quicksort, the sorting of n elements, right? The n by 5th smallest element selected as a pivot using order of n time complexity algorithm. Then what will be the worst case time complexity of quicksort? Remember, n by 5th smallest element selected as a pivot using order of n. Pivot selection is order of n. Right? When you select the n by 5th smallest element as a pivot, right? Pivot element will go to its correct place, n by 5th place. Left side is n by 5 minus 1. Right side is remaining. Right? If you solve this one, you will get n log. Right? So remember, n by 5th smallest element as a pivot. Now let's go to another problem. So remember, n by 10th smallest element. Same story, n by 10th smallest element. Using pivot selection is using order of n square time complexity. Order of n square for pivot selection, n by 10th smallest element, left n by 10 people, right is remaining people. So if you solve this one, n square. Right? So next one. So can you see this one? In sorted array of n elements, if you take middle element as a pivot, sorted array, if you take middle element as a pivot, then time complexity of quicksort is n log n. Right? If you take the middle element as a pivot, sorted array middle element, which is nothing but a median. The middle element in the sorted array gives median. So always the best partition it will happen, which is nothing but n by 2. Median means what? N by 2 smallest element. What is the meaning? Sorted array middle person. Sorted array middle person, if you take as a pivot, it will give best partition. Whenever you say it is giving best partition, time complexity become order of n log n. So time complexity to find median of n elements, right? Order of n using median of 5 algorithm. To find out median in order of n time, you are using one algorithm, that is median of 5 algorithm, right? It's there in the core main. You can please go through it and you can check. I think all the points, whatever is important, I kept here. Whatever important I kept here, please go ahead. Quicksort, merge sort, whatever is required, I done. If I keep everything how it is a short notes, right? Whatever is important, I'm keeping, right? Next one, Strassen's matrix multiplication, more not required. Just remember only this. Strassen's matrix multiplication, just remember only this, right? I think recurrence relation is 80n by 2 plus n square. If you solve this one, I think it is the actually, right, matrix multiplication using divide and conquer, 80n by 2 plus n square. Using Strassen's, it became 70n by 2 plus n square. 70 n by 2 plus n square. If you solve this one, you will get n power 2.81. Just remember this, right? One question also not there. Just remember only this. If you want, you can remember this also. 18 into n square by 4, right? So if you want, you can remember, but actually this is more than enough. That is the Strassen's matrix multiplication. Next one, counting a number of inversions. Remember, what is the inversion? In the array, if you take two people, positions are less than, but values are greater than. That is called inversion, right? This problem can be solved exactly merge sort. Exactly merge sort. Using merge sort, you can solve it. Time complexity n log n, space complexity n. Let's go to heap sort. Some people are asking, why Reddy sir is reading this entire story? Why Reddy sir is reading total? He came in the name of short notes. Why he is reading total? He is reading one by one. मैं क्या करो? You only say. Bhaiya, you only say. मैं क्या करो? Other than reading, what I can do? Then what is the meaning of short notes? Everyone is saying, Arey, this person is came and is reading. बोलो तुम बोलो ना मैं right मैं क्या करूंगा बोलो. Other than reading, what can I do? This is the meaning of short notes. Na? Short notes means reading only. So what I kept, we have to see. Oh, short notes is like this. Okay, fine. Right, now let's come to heap sort. Let's come to heap sort. Right, remember everyone, heap sort. Heap sort is, right, if you see the heap sort, it is in place. Within the array only you will do. Okay, it's unstable. Right, in the heap sort, now you are going to swap like this. Right, so last element, when you delete root element, root element replaced by last one, because if you are swapping like that, sometimes repeated elements order is changing, so it's unstable. Right, and one more, heap is an almost complete binary tree. Okay, next one, what is almost complete binary tree? Without completing upper level, you cannot go to the lower level. In between gaps not allowed. That is the meaning of almost complete binary tree. Right, if A, C, B, T and CBT contain n nodes, number of leaf nodes are n by 2 ceiling. Just to take, right, just take one example and check. Right, and one more thing is number of non-leaf nodes are, one is ceiling, another one is floor. You take one example and check. You check simply in the ACBT, CBT, half nodes are leaf, half nodes are non-leaf. If fraction will come, ceiling is going to be leaf nodes, right? Next one is going to be non-leaf nodes or floor. Take one example and check. You will get the clarity. Don't by heart anything. If node is stored in array representation at the ith place, then parent of I is I by 2. It is also floor. Left child of I is 2 into I. Right child of I is 2 into I plus 1. Max heap at max heap will give ascending order. Min heap will give descending order. Insertion, deletion in the heap, best case is 1, worst case, average case is log n. Exactly. Next one, heap sort time complexity is n log n, every case. Creating max heap or min heap using build heap method order of n. Excellent points I written. Trust me, I written the excellent points. Everything I written in one place. Heap sort, everything I written in one place. Sir, test में marks are 55 से ज़्यादा नहीं आ रहा है. Okay, 44, 49, 50, 46. I think it's perfect. क्या करूँ? Silly mistake ज़्यादा हो रहा हो. 10 to 11 marks के. Okay, Ross, thanks for informing, Ross. It will happen like this, right? Try to minimize as maximum as possible. Try to minimize the errors. One test to another test. Try to minimize. Any mistakes are there, rectify. New mistakes are okay. New mistakes are okay. Old mistakes rectify. Old mistakes rectify. New mistakes are okay. Old mistakes rectify. Right? So you are doing really nice work, Ross. Ross, please continue. Ross, please continue. Ross, I request everyone, right? Please continue similar way. Don't stop. Don't stop. I request everyone, please don't stop. Right? This is my sincere suggestion to all the people. I request everyone, please don't stop. Right? Fine. So I think heap sort I done. Let's go to bubble sort. Heap sort also done. Let's go to bubble sort. Bubble sort nothing. See this one, bubble sort. Bubble sort total comparisons, right? I think one element is compared with all other elements, right? First pass n-1, second pass n-2, third pass n-3, and so on. Lastly, one sum of n-1 natural number, n into n-1 by 2. if at all n natural number, sum of n minus 1 natural number, right? So let's see, first time how many comparison? N minus 1, second one n minus 2, sum of n minus 1 natural number. Then what is the answer, right? So let's see this. Okay, sum of n natural number, n into n plus 1 by 2, right? So here it is going to be n minus 1 into n, right? N minus 1 into n by 2. Yeah, same story. I'm repeating once again, sum of n natural number, n into n plus 1 by 2. The sum of n natural number, but here sum of n minus 1 natural number. N place keep n minus 1, right? N minus 1 plus 1 n by 2. Okay, these are total number of comparisons for bubble sort. The time complexity is n square, right? One square, right? Every time one scan, like that n times you will do n square. It is a stable and it is in place. In every pass, largest element will go to at the end. I think major points all I written. Major points all I written. Right? Everything I written. Next one, while applying bubble sort. See, it is a very, very important one. While applying bubble sort in any pass, number of swaps are 0. Stop, because right array is already sorted. With this modification, bubble sort best case is n. Worst case, average case, n square. It's a very, very important one. Please take care. This is the only important point in the bubble sort. In the examination, anyone asks you what are the bubble sort best case time complexity, say order of n. How? By adding one small condition. In any pass, number of swaps are 0. Stop the algorithm and say, right, array is sorted, so no need to proceed further. That is the bubble sort. Let's go to selection sort. Selection sort is unstable. So in the selection sort, now what happened is, right, first pass is over. First pass is over, right? First minimum will come to first place. Second pass over. Second minimum will go to second place. While doing that, na, second minimum is somewhere here. You are swapping to second place. Second minimum somewhere here. You are swapping to second place. But interesting thing is here there may be similar element. It is a here also a there. It is coming to here. Because of this reason, na, because of this reason, right? Because of this reason, it is not stable. But within the array you are doing, it is in place. So you are swapping there. In the case of the right selection sort, now you are swapping. The person who is there in the second place, see, E should be there in the second place, but E is there in the second place. So B will goes to here. B will goes to here. But B is going to here, that is okay. A is coming here, that is also okay. But interesting thing is, in between one B there. It may be, right? It may be, right? See, if you observe clearly, the first B is the second B. But because of your swapping, second B become first B becomes second B. That is the reason, right? Selection sort is not stable. It's an in-place algorithm. Because within the array you are doing, but because of it is a selection sort, no, nothing new, right? N passes, right? Approximately n minus 1 passes, every pass n time, so order of n square. Every case n square. It gives minimum element, right? The purpose of the selection sort, everyone know, right? Minimum number of swap operations. In the worst case, it will give minimum swaps because you don't swap every time. Lastly, you will do one swap. Because of that reason, it is not stable. Because of that reason only, it is not stable. But in every pass, one swap only. In the bubble sort, every time swap is there. In bubble sort, every time swap is there. But here, in every pass, last place, one swap is there. Right? Let's go to insertion sort. Let's go to insertion sort. Insertion sort is stable. It is in place. Within the array, you will do. Right? Best case, order of n. Worst case, n square. Average case also n square. Right? Here, important thing is number of swaps is equal to number of inversions. In the insertion sort, the number of inversions is equal to the number of swaps. If the array is already sorted, then insertion sort algorithm will give best time complexity than any other sorting algorithm, that is order of n. If array is already sorted, you will give best performance. But if array already sorted, who will apply sorting? No one will apply. No one will apply sorting, na? Right? So please careful. Next one, sorting algorithm overview. Whatever we discussed, I kept everything in the form of a table. Sorting algorithms overview. These are the things. Right? Bubble sort, selection sort, insertion sort, merge sort, quick sort, heap sort, all the things I written. Check one time. Check one time. Remember, other than reading, nothing is there. Any small doubt also, something you are not accepted. Ready, sir? I didn't accept this. Sir, bubble sort by default optimized. if in the exam they ask you, Raj, in the exam they asked you, what is the bubble sort best case? Say order of n. Because by doing one small change, by doing one small change, best case is coming. Just adding small change. If they ask you best case of bubble sort, just say order of n. After exam is over, if they say bubble sort best case, say every time order of n. Right? Someone is saying radic sort. Yeah, you can study those also. But very rare they are given, because I cannot keep everything here. Right? You can study that also. 1 or 2 times they asked that also. Please take care. Right? Major sorting algorithms, all I written here. Major sorting algorithms, all I written. So please go through it. Someone is saying that, sir, only heap is given. Remember, sorting means normally ascending order. Who will give ascending order? Max heap. Whenever they mentioned only heap, max heap. If they mentioned only heap, max heap. Why? Max heap will give ascending order. Sorting means ascending order. Max heap will give ascending order. That is the reason. They will say min heap or max heap. Suppose if they say heap, then go for max heap. Right? Fine. Perfect. Perfect. So I hope everyone is fine. Right? So few points I covered. I cannot cover. If I keep everything, it will become a not short nodes. It will become a maximum, right? Large nodes. If I keep everything, it will become a large nodes. If I keep everything, it will become a large nodes. It is not a short nodes. So I kept whichever I feel important. I kept some problems also. I kept some problems also. I kept. Be careful. It's only for reference. One time reference. If you think somewhere, right, Reddy sir, somewhere some small mistake happened, let me know. I will rectify. Somewhere small mistake is happened. If you want to say to me, say, I will rectify it. That is the purpose of live class. I can give recording also. Why I given the live? Why I am giving live? So that at anywhere, if you have doubt, you can ask me. Right? Perfect. Perfect. Yeah, I'm thinking that everyone is fine. Let's go to, I think I completed the divide and conquer. I completed divide and conquer. So let's go to, right, greedy technique. See the greedy technique. Everyone be careful. Everyone be careful. Greedy technique. See the greedy technique. Fractional knapsack problem. Fractional knapsack. What is the fractional knapsack? Fractions also you can take. Calculate the profit by weight ratio. Okay. So calculate the PI by WI ratio. Okay. Sort, right? Sort accordingly. Take the larger one first. Sort in the descending order. Then take one by one. So which will take because of your sorting n log n. Because of it is a greedy, small algorithms, they are very easy also. Job sequencing with deadline, right? Best case is n log n, worst case n square. Please go through it. Numericals, most probably numericals will come here. NAT type questions will come from here. Mostly NAT type problems will come here. Go to the optimal merge pattern. Here also, time complexity n log n, using the heap. Using the heap you can do. Using the heap, you can do n log n time. Here also you can expect your NAT type. Huffman coding, more frequency, less bits. That is the idea. Right? Construction of tree. First minimum, second minimum. First minimum take, keep on the left side. Second minimum you take, keep on the right side. Add it. Continue this. Every time 2 minimum, 2 minimum, 2 minimum. So 2 log n, 2 log n, 2 log n, 2 log n. Like that, how many times? N minus 1 time. Right? I think 2 log n into n minus 1, which is going to be n log n. Time complex. Here also you can expect numerical. Here also you can expect numerical. These are very simple. One time, please go through it. Most probably you can expect one question from this. If you are lucky, you may get 4 marks from this. Now let's come to the spanning tree. It will come mostly. It is a compulsory question. Spanning tree. Spanning tree. It's a compulsory will come. It will come compulsory. It will come compulsory. Please be careful. Be careful, everyone. It will come compulsory. Right? Spanning tree. It should cover, right? What is the meaning of spanning tree? Covering all vertices. Right? But what is the one more thing? V minus 1 edges. If at all V vertices, V minus 1 edges. It cannot contain cycle. That is the meaning of spanning tree. Spanning tree means covering all and all edges, right? All vertices should be there. Yes. But to cover all vertices, V vertices are there, V minus 1 edges required, and it cannot contain cycle. Okay. Now to find out minimum cost spanning tree, right? How many algorithm? We have Kruskal prims, Kruskal time complexity. You are using min heap. Min heap creation is E. Afterwards, every time log V, log V, log V, like that, V minus 1 time. That is the best case. Best case. Worst case, all edges you delete. Right? Every MST must contain first minimum, second minimum edges. Okay. Right? So first create min heap. Okay. Next one, if you are lucky, log V, you are keep on deleting one by one edge, but I want only V minus 1 edges. So V log V. Right? E plus V log V. Best case. Worst case, E plus E log V. So finally E log V. So every minimum cost spanning tree must contain first minimum, second minimum, right? Remember, first minimum, second minimum. If edge weights are distinct, some conditions are there. Every MST should contain first minimum, second minimum, provided all edge weights are distinct and the number of vertices are, right, 3 or more than 3. Number of vertices are 3 or more than 3 and the edge weights are distinct. Compulsory first minimum, second minimum will be there. Right? Fine. Okay. If the graph is connected, then at least one MST possible. Every connected graph, you can find out at least one MST. Next one, if the graph, right, if the given graph, all edge weights are unique, then unique weight, then it has to at most one MST. Edge weights are distinct, unique MST possible. Only one MST, at most one MST possible. So Prim's algorithm, right? Prim's algorithm, you know very well. Using this is a very, very important one. This table is very, very important. I'm saying very clearly, you can expect one question from here. You can expect one question from here. Understand everyone. Understand everyone, right? So compulsory Prim's algorithm question will come. Time complexity means this is the area. Time complexity means this is the area. So I will minimize also. I will minimize also. Time complexity means this area will come. Right? Min heap and adjacency list. Min heap and adjacency matrix. Unsorted array, adjacency list. Sorted array, adjacency list. Please careful. It is there in your notes also. You cannot by heart. You cannot by heart. Please go ahead this. It's a very, very important. Prim's algorithm, time complexity. Min heap and adjacency list. So left hand side, if you observe clearly, I still in my brain there is a image. Right? Prim's algorithm image is there in my brain. So left side every time log, right? Log V, log V, log V, log V, V times V log V. So right side, if you see, right side, if you observe clearly, so creating min heap. First min heap should be there. So left side is V log V, creating min heap is V. Next one, right? Adjacency checking. Adjacency checking every time is, right? I think everyone is checking their adjacent to E. Now, next one is how many edges are there at every edge. You done the, right, decrease key operation, E log V. So min heap adjacency matrix. So it's going to be V square, remaining all are same. But unsorted array. So left side is every time you have to delete minimum. You don't know where is the minimum. So V square. And one more thing is initially to initialize all of them, maybe V. Right, next one, adjacency list, 2E. And one more thing is a decrease key operation. So if you observe clearly, decrease key operation, E time, every time is constant because it's anyhow unsorted, constant into E. So sorted array, some people are asking, sir, Reddy sir, I am not getting. You don't get, bhaiya. Someone is saying, Reddy sir, I am not getting. Someone is saying, right, BFS, DFS, hoga, right? It is there in the DS. Tomorrow we'll discuss. It is there in the DS. Tomorrow we'll discuss. It is an algorithm. Right? So I have to divide somehow. Actually, I cannot divide, but I have to divide somehow. So I divided. Right? In tomorrow's algorithm, right? We'll see that. So remember, this is compulsory going to come. Time complexity means it will come. Be careful. Time complexity means it will come. Understand everyone. Time complexity means it will come. Right? Fine. Perfect. Next one, sorted array and adjacency list. Sorted array, every time minimum constant V. But initially sorting, right? Initializing purpose V time. That is okay. That is not a big deal. That is not a big deal. Initially, initializing all are something like minus, all are like infinite, infinite, infinite initially, right? For initialization purpose, V. Next one is every time, right? Every time deleting minimum, minimum, minimum. Sorted, na? Sorted, right? Deleting minimum is constant like that V time. Next one, adjacency list, na, to E. Now here, right? Because of it is unsorted to far, right? So to do decrease key operation, see this one, sorted. Sorry for this, sorted. To do decrease key operation, not only doing decrease key, how to keep in the proper order. Every time one scan record E times EV. It's very, very interesting. See, I done many times in my brain, it is available. That image is available in my brain. Right in my brain, that image is available. It may not be available to you. You may not be getting it. Some people are saying that, sir, I'm not getting what you are talking. Are you mental? Of course I am mental. Right? Total algorithm, which is almost like, right? Which is almost like, I can say 2 months, right? If I teach the algorithm properly, 2 months, I have to say in 1 to 2 hours. Other than reading, I cannot do anything. Just only reading is going on. Only reading going on. Lecture means what? Mental person only. The person who is teaching is a mental person. The people who are listening, they are also mental. They are also mental, right? So listening people also mental, teaching person also mental. Why? What is the reason? Right? 2 months story I have to say in 2 hours. Other than reading, nothing there here. Just reading is going on. Anywhere wrong, let me know. The purpose of this one is what content I kept. The purpose of this one is what content I kept. If I keep everything, it will become a long notes. Right? If I keep everything, it will become a long notes. No, I want to make important points here I kept. So let's come to Dijkstra's algorithm. Let's come. Right? Dijkstra's algorithm, Prim's algorithm, same. It is called as DK's algorithm. DP's algorithm. Dijkstra's and Prim's algorithm. These two are same. Whatever I explained above, below also similar. Purpose is different. Small modification if you do, it will become Dijkstra's. If you do one more small modification, it will become Prim's. Both are same, different names. It is something like two bodies, but right? Physically bodies may be two, but Atma is only one. There are some people are there, true lovers. There are some people are there, true lovers, right? Why we can say they are true lovers? Because bodies are two, but heart is only one. People used to say, this Raz used to say to me, sometimes Raz used to call me, right? Sir, me and my lover, we both are same. I asked why we both are same. Sir, physically we both are same, sir, but logically we are one, only one heart. Two people, one heart. Oh, so that is the same. DP's algorithm also same. Dijkstra's, Prim's algorithm same. Dijkstra's and Prim's algorithm is same. Right? Only names different, but algorithm is same. So it is similar to Prim's algorithm. Just we need to add the previous cost also, some difference. Time complexity analysis of Dijkstra is same as the Prim's algorithm. Exactly. Yeah, exactly. Let's go to Bell-Manford algorithm. Let's go to Bell-Manford algorithm. See everyone, Bell-Manford. Time complexity. Bell-Manford, na, every time E edges, you will. In every round E, like that, V minus 1 rounds. You will do that. So VE time complexity. If the graph contain positive edge weights, na, then Dijkstra's and Bell-Manford both will give correct answer. All positive edge weight, Dijkstra's, Bell-Manford both will give same answer. Correct answer also. If the graph contain negative edge weight, but negative edge weight cycle not there, only negative edge weight, then Dijkstra's may fail, but Bell-Manford will always give correct answer. Okay, that is also okay. Let's go to next one. If the graph contain negative edge weights, and negative edge weight cycle also, then Dijkstra's always fail, and Bell-Manford will give wrong answer for those vertices which are involved in the cycle. So if the graph contain negative edge weight cycle, no one will give correct answer because it will go to infinite. Minus infinite means it's not possible. Infinite means Infinite means practically not possible. Very small value I can say, but practically not possible. Means undefined, means not possible. So be careful. If the graph contains negative edge weights and negative edge weight cycle, then Dijkstra's will fail, right? Bell-Manford also will fail, who are part of the negative edge weight cycle. For them, it cannot give correct answer. Okay, perfect. Bell-Manford algorithm is a dynamic programming. Bell-Manford algorithm is a dynamic programming. Will it use the previous data? Will it use the previous data? And it is covering all possibilities. Because of it is covering all possibilities, you may say dynamic programming. Because it is covering all possibilities, you can say it is a dynamic programming. Right? Fine. Perfect. So I think we done the right. We done the greedy technique also. Right? I read this so fast. Yeah, I think that is the meaning of right short notes. Any small doubt is there? Ask in the right. Ask in the chat. I am going to help you. Right? Now come to dynamic programming. Now come to dynamic programming. Everyone try to understand. Come to dynamic programming. Fibonacci series. Fibonacci series without DP, na Fibonacci series, one binary tree there. So I think time complexity 2 power n, right? Level is n level, Fibonacci of n level. So time complexity 2 power n, right? So right, space complexity n. Yeah, just give me 1 minute. So mouth is I think. Yeah, perfect. So Raj is saying that Dijkstra's will always terminate, of course. See, Bell-Manford also will terminate. See, that is the meaning of algorithm. Na? Algorithm means terminate. If something is not terminating, how it is an algorithm? Ross, something is not terminating, you only say how it is an algorithm. Right? Algorithm means it will terminate. Okay, fine. So Fibonacci series, I think n level. So stack space is n. So space complexity n, time complexity 2 power n. Time complexity 2 power n. Okay, with DP, only distinct function calls you will do. Time complexity n, space complexity 1 more n, totally n. Okay, fine. Let's go to, right, understand everyone. Mostly this one, right? You can expect numerical. LCS numerical or time complexity. Mostly you can expect numerical in this area, right? So see the time complexity. Without DP, time complexity, if you observe, without DP, best case, every time matching, see, every time, LCS, every time matching, see. So you can stop it. Right? One sequence is over, other sequence still left out. So every time matching. Best case is minimum of m comma n. Worst case is 2 power m plus n. Worst case, average case. Without DP, right? This is the story. So I think m plus n level 3 will come. M plus n. With DP, right? In the DP also there are two things are there. Right? If you do first, right, from the top to bottom, right, top down approach, if you do top onwards, you will start in the form of a tree, in the form of a tree you check, right? So from the top onwards you will start like this. It is top down approach, right? This is also called a memoization. When you coming from top, every time you ask, is it available? Yes, then don't go further. Not available, call further. Is it available in the table? Yes, then stop it. If not available, call further, right? So from top onwards, you will start. You will keep on going down until your required thing will come. If there, you no need to go down also, right? Let me start now. 0 by 1 knapsack. If you see 0 by 1 knapsack, now for every element, two possibilities are there. For every element, there are two possibilities. You may take, you may not take. So without DP, time complexity 2 power n, right? Without DP, time complexity 2 power n, worst case and average case, best case is n. So best case means every time only one possibility, right? Every element having only one possibility. So best case is n, worst case is 2 power n. Space complexity, if you see, I think n level 3 you will get. N level 3 you will get. So I think stack space is n. Stack space is n. So that is a knapsack without DP. Let's go to with DP. With DP, if you observe, If you, right, with DP, if you observe, there are two parameters which are keep on changing. One is going to be capacity of the knapsack is keep on changing. Number of objects also keep on changing. So there are capacity M, number of objects are N. So because of these two parameters are keep on changing, so I think a tree will come with those parameters only. The things which are not changing, with that tree will not change. So in the tree, everywhere those two parameters will come to the picture. What is the capacity of the knapsack? How many objects are there? Based on that only, that parameter. So time complexity, if you see, order of Mn. Right, worst case, right? Best case is same, right? Everywhere one possibility. So space complexity, if you see, you have to manage one table, right? Order of Mn, worst case. Best case, if you see the table, maybe something like this. Only one path you will go. Only one path will go, right? Just, however, I request everyone, please go through the entire notes once. This is only for right, revision purpose. One time just giving idea. I request everyone, please go through the notes one time. If something not clear, go through the notes. If it is already clear, right, if it is already clear, so you don't need to go. Something, whatever I am explaining, little bit not clear, you can refer the original notes, right? Let's go to matrix chain multiplication without DP, with DP. So without DP, if you see matrix chain multiplication, there are n matrices. I think there are so many possibilities are there. I think you will get the n level tree, right? N matrices are there. Almost you will get the n level tree, n level n array tree. N level n array tree, right? So I think breadth also n almost, depth also almost n. So in the previous problem, breadth is going to be almost like a binary tree. Depth is n, but here breadth also n, depth also n, so n power n, time complexity. Space complexity based on the number of levels, so n. With DP, if you observe, all possibilities you have to do. It is almost like, right? Almost like there are two parameters, starting parameter, ending parameter. From which place to which place you are multiplying. The parameters are keep on changing. These two people will keep on change. From which place, right? So what is the meaning of matrix chain multiplication? From where to where I have to multiply. There are so many ways. Are there you can multiply. So always there are two parameters important. From where to where, starting point, ending point. That is the reason I think because of these two parameters are keep on changing, starting and ending. Starting can be out of n anything, ending can be out of n anything. So n into n square. N square table required. But every, right, after doing this, every time I have to find out the right I think the matrix chain multiplication, minimum number of multiplications required. Every time out of n you have to find out minimum. Out of n to find out minimum n time. So n square is the table size. Distinct function calls are n square into n cube. Space complexity is a table size, which is going to be n square. So I know very well, everyone know this. Someone is saying that, how can I get these notes? Yeah, I may share, right? So first listen this, I may share. First listen this. Listen. I will keep the link also. In the video, I will keep the link also. Right? From there, you can download it. Right? No, you no need to feel bad. Right? First listen, and afterwards you can download the notes. Next one, sum of subsets problem. It is like 0 by 1 knapsack only. Sum of subset 0 by 1 knapsack, both are same. No more discussion needed here. Let's go to next one. All pairs shortest path. Remember this equation. Recurrence relation, you remember. Right? I think here if you observe, everywhere there are two parameters. It is a one more parameter. There are two parameters. It is a one more parameter. So totally almost like a one table containing n square slots, like that, right? Like that n times. So n cube time complexity. Right? But tables are, I think you are keep on reusing. It is the input, it is output. You are keep on, right? It is a previous one, it is the next one. Tables you can keep on reuse. I think, right, one or two tables you can manage. Space complexity n square, time complexity n cube. right? Time complexity is going to be n cube, or space complexity becomes v square or n square. If one matrix has a row major and other matrix is a column major, then will time complexity affected or independent? Means to do what purpose? Two matrices are there, okay. What you want to do? Let me know. Two matrices are there, I am happy. But what you want to do that? So please go through it. This is the total DP. It's a DP story. Write properly. Lord Voldemort. Lord Voldemort. Matrix multiplication. Matrix multiplication, so there are, right? They don't give elements, right? Matrix multiplication, they don't give elements. They will give simply how many rows, how many columns, right? In the matrix multiplication, we don't do, right, matrix chain multiplication. We are talking about matrix chain multiplication. So if you go to the MCM, matrix chain multiplication, right? This is a MCM. Matrix chain, it's not a matrix multiplication, matrix chain multiplication. Here they will give n matrices, and every matrix rows and columns you will give. You don't give elements. You don't give elements. By default, row major order only. By default, row major order only. Thanks for asking. But anyhow, that is not important. Yeah. So please be careful all these things. One time I want to remind everyone. So I done this. Now come to right, hashing. Now concentrate. In my opinion, today's class is just started now. In my opinion, today's class is just started now. Please be careful. Today's class is just started now. Actually, whatever I done yesterday, continuation little bit left out. So just I done it. Now I think, let me write 222. Let me write it. 22, 01, 26. 22, 01, 26. Right? 22, 01, 26. Please be careful. Hashing is going on. Right? So this is the today's class starting point. Make sure everyone listen. This is the today's class starting point. Make sure everyone listen. Right? Fine. So here from the hashing, you are going to expect one question or two questions. You can write 1 mark or 2 mark expected. 1 mark or 2 mark expected. So please go through it one time. Right? Whatever I am saying, just listen one time, just followed by, if anyone is not done, five or 6 problems you can practice. Whatever I am saying, you listen, right? You may get 1 mark or 2 mark. So, and one more thing is 5 problems. If anyone is not done practice, just to do 5 problems practice. If you do more advantage you will get. So let's start now. First one, the goal of hashing is searching time is order of 1. That is a goal. So what is the collision? In the hashing, what is the meaning of collision, right? If more than one key mapped to the same slot in the hash table is known as collision. Next one, collision resolution technique. Collisions can be resolved, right, inside or outside. Outside is called chaining. Outside. Inside is called open addressing. When collision came, you can go outside, or you can manage inside only. Inside, if you manage, that is called open addressing. Outside, if you go in the form of a chain, that is going to be chaining. Right? Right, fine. Next one, inside how? Inside, if you go slowly, that is a linear probing. Little faster if you go quadratic probing. If you go more faster, double hashing. Right? So yeah, so collision resolution techniques are 2 types. Inside you are storing, outside you are storing. Inside, that is a open addressing. Outside in the form of a chain. So I think it is going to be chaining. Inside how? Slowly linear probing. Quadratic probing is a little faster. Double hashing means more faster. With this recording, is this recording available? Of course, it is a YouTube, right? It is available. Now come here now. Chaining. Careful about the chaining. You are storing outside the hash table, not inside. When our collision came, in one slot, many people came. So you will keep in that slot in the form of a linked list. See, 0th slot, 3 people came. First slot, 3 people came. Second slot, 1 person came. right? Third slot, no one is came. Fourth slot, 2 people came. Fifth slot, 6 people came. Sixth slot, 1 person came. Seventh, no one is came. Eighth, 2 people came. Ninth, 4 people came. Right? You are storing outside the hash table, not inside. So we are using lots of space outside. Benefit. What is the benefit? Because of anyhow you are going outside, infinite people you can store in the form of a linked list. This is the greatest advantage. I'm keeping in some other color also. I'm keeping in some other color also. It's the greatest advantage with the chaining. If anyone asks you with the chaining, what is the greatest advantage? This only. Benefit is going to be we can store infinite data outside using linked list. Okay, fine. Next one, right? Chaining, right? See this one. Some people are asking, how will you implement chaining? Some people are asking, how will you implement chaining? I think it is nothing but array of addresses. Array of addresses. How will you? Array of pointers. In the case of, right? If you see in the case of the C language, it's going to be array of pointers. Every language, some using some technique you can implement. Here you are using array of pointers. Array of pointers you can implement. So here everything, right? So I think you can say is address. Using address you can implement. See here address you are going to store. Array of pointer, here you can store. So if you store, right, if you are storing one linked list address, here one more linked list address, one more linked list address, one more linked list address. So many linked lists you create, so you will create like that. So chaining will be implemented by using array of addresses. That's okay. Next one, what is the maximum chain length? They may ask this question. Please careful. They will give some data. They will ask you, if you do chaining, what is the maximum chain length? I think in this problem 6. What is the minimum chain length? I think some people will do small mistake. Minimum chain length is not 1. Minimum chain length is 0. Next one, what is the average chain length? Average chain length means all the chain lengths add, divide by total number of slots. I think 10 are there. If you add total, you will get this much. By 10 you do. Total slots are 10, 0 to 9. Right? Every chain, right? I think first chain if you see 3, second chain if you see 3, third one if you see 1, fourth one is 0. So I think right, I think if you start from 0, 0th one is 4, first one is 3, second one is 1, third one is 0, fourth one is 2. Add all of them, divide by how many slots are there? 10. Then you will get the average. Please be careful, then you will get the average. Now in the chaining, what is the searching time? Suppose assume all elements went to the same slot. If all went to the different, that is the best case will come. Best case 1. If all elements went to the same slot, worst case and average case will come. So chaining best case is 1, worst case and average case becomes n. Okay, perfect. Deletion. If you want to delete, first you have to find. If you want to delete, first you have to find. Same story. So see this one, deletion time. What is worst case? What finding is n. Then afterward deletion may be constant. Next one, best case finding is 1. Afterward deletion is constant. So if all are in the single sequence, single linked list, right? Suppose all are placed in the right different places, then best case. Now deletion, how much time? See this one, address of a node is given, double linked list, right? You want to delete in the chaining a particular node, but that node address is given. So it is a linked list. It is a linked list. In the chaining, one of the node which you want to delete, that node address is provided, and it is a double linked list also. This node is address is provided, and double linked list also means you can go back. Then what is the answer? So you can go back. So you can link both of them like this. So you are already here. If you want to delete a particular node in the chaining, that node address is provided. Just go directly there. You can go back also. Go like this. You can change the address like this. Change. Afterwards, delete it. I think this one everyone know. If anyone having some small doubt also, let me know. So I think deletion will take how much time? Right? Because of address is already provided, constant. Address is provided, but this single linked list, not double linked list. When you say address is provided, it is a single linked list, not double linked list. You cannot go back. Remember, you cannot go back. Because it is a single linked list. Then you have to start from here. You have to come here. That time it will take order of n. Please be careful. This point is very, very important. In the chaining, deleting someone will take how much time? If you don't mention anything, right, first 2 points. In the chaining, deleting someone will take how much time, right? Node address is provided and double linked list also, then 1. In the chaining, deletion will take how much time? Node address is provided, single linked list, then end time, because you cannot do directly, right? New key insertion beginning or ending. I think that is a very interesting, very interesting. I think I didn't written here, so I will write here. See, insertion time. In the chaining, insertion time. Please be careful. Insertion time is always order of 1. Always you can add at the starting. What is the requirement of adding at the end? No need. It's a very, very important point. It's a very, very important point. In the chaining, you can insert. Just apply as function. You will go to some slot. In that slot, so many people are there. You no need to go to last and you no need to add there. You can add starting itself. Insertion time is order of 1 always. In the chaining, this is a very, very important one. Thank you so much, Lord. You are my Lord. You are my Lord. Thank you so much. Thank you so much. Insertion time is order of 1 always. Okay, perfect. This also okay. This also okay. Let's go to open addressing. Let's go to open addressing, right? Means inside. Slowly if you go linear probing. Fastly if you go quadratic probing. Right? If you go more faster, double hashing. Right? So remember everyone. Mostly this will come in the exam. Please be careful. Mostly this will come in the exam. Be careful. Mostly it will come. Practice few problems. I cannot say all here. If I say all, it is not a short notes. It will become a big notes. Right? So linear probing 1 by 1. Suppose this is the hash table. You applied the hash function. You came here. It is already full. Then you will go to next. It is already full. You will go to next. That is called linear. Slowly you are going. 1 by 1. What is the best case? As soon as you go there, space there. Best case 1. What is the worst case? Right? Worst case, what you have to do is you have to check 1 by 1. There are right. So I think let us assume that how many table size, how much? For all I belongs to 0, 1, 2, 3, m minus 1, right? So m slots are there. Worst case, you have to try all the m slots. Something like that. So worst case m, average case is m. Right? Fine. Quadratic probing means same story. When you got the collision here, instead of trying next one, you will apply this quadratic function, right? As function of key plus I square. You will do wherever it will say, it will go from here. You may jump here. So because of some jumpings are there, little bit faster, but remaining all will be same. So best case is 1, worst case, average case is m. It became little faster. Because of jumpings, but some side effect also there. Because of your jumping, empty slots you may leave. But anyhow, so that is a searching time, deletion time, insertion time, double hashing, 2 hash function. So you have a problem here. See this one. You have a problem here. Collision came here. Let's see. Collision came here. So whenever collision came in the linear probing, next one you try. In the quadratic probing, you will try somewhere. But in the case of the double hashing, second hash function, whatever it will say, I will go. Second hash function will say, go to here, I will go. Second hash function say, go to here, I will go. Right? Simply here, you will use the second hash function. Whatever second hash function they will use, that one I will use. This is also same, but because of 2 hash functions you are using, the average case becomes order of 1. Previously, only 1 hash function. One hash function itself don't give collision. Sometimes one hash function may give. So worst case, right? Worst case, one first hash function may give, second one may not give. That is the reason, because of you are using second hash function, average case you can. It's almost like 2 chances. You are taking 2 chances. In the double hashing, you are taking 2 chances. One hash function having problem. Normally hash function don't have problem because best one we will select. But unfortunately, one hash function having problem, right? So you will apply second hash function, which may resolve it. So that, right? That is the reason average case becomes order of 1. because of 2 hash function. In the above one, comparing this one, comparing linear probing, quadratic probing is little improved, not fully. So here constant factor improved. Comparing linear probing, here constant factor improved. Here constant factor improved, but here average improved, which is became order of 1. So next one, m slots are there, n keys are there. M slots there, n keys are there. Load factor alpha is equal to n by m. Remember this formula. Right? Remember m slots, n keys. See this one? In m slots, you want to keep n keys. Right? So in one slot, how many? Which is going to be n by m keys per slot. This is called load factor L. This is called load factor L. One, right? One slot, how many? That is called load factor. Load factor alpha or load factor some L is equal to n by m. Remember. If alpha value, if load factor value is right minimum 0, maximum 1. Maximum 1 means inside table you are storing. That is called open addressing. Next one, if alpha value is more than 1 also possible. I think in the chaining, in the one chain, you can store more. Infinite people are storing, that is called as open, that is called chain. Alpha value more than 1 also possible. Chaining. Alpha value is maximum 1, open addressing. Remember everyone, right? So because of you are storing outside anyhow you are storing. If you delete someone, because of it is a linked list deletion is easier. In chaining, deletion easy. In open addressing, inside you are storing, there is a lot of dependency. Deletion is not easier. Possible, but not easier. It is a very, very important one. Theoretical one you may get. Theoretical point you may get this. Theoretical point you may get this. Right? So see, remember some points you may not get because I am saying total subject one time. Total subject I am saying one time, 1 or 2 points you may not get. So whichever you are not getting, please revise once. Go to that area, please revise once. No need to confuse. I am not great, you are right. It is not like I am great, you are not great. Because I am prepared. I prepared before coming. I taught this subject many times. And before taking this class, I prepared also. Before explaining this class, I keep on reading. I know what I am going to teach. All right, I explained. I already revised many times. So you may not, unfortunately, one of the point if you are unable to get. One of the point you are unable to get. Nothing is there. Nothing. Just revise. Go to the actual notes and revise one time. Next one. The expected number of probes in an unsuccessful search of open addressing is, right, 1 by 1 minus L. This formula everyone know. The expected number of probes in a successful search, 1 by alpha, right, ln, 1 by 1 minus alpha. Ln means base E, log only base E, right? These two formulas already there in the class notes. Please take care. Next one, some theorems also there. Can you see this? Can you see this one? These theorems also. Those people who are watching, so please see this. You all the right. These all theorems you have to remember one time. Right? They're already there in the core man proof also there. Please go through it. Please go through. For your convenience, I written all these. One time you have to see. Theorem number also I written. See, theorem 11.1, theorem 11.2, 11.3. Until now they didn't ask. They may ask also. I am able to see from the core man directly they are copying. From core man directly they are copying. Please, can you see this? Please, can you see this one? This is also one more theorem, please, right? It is almost like this is the same point, right? I think inserting an element. If you want to insert, element cannot exist already, means unsuccessful. Inserting an element, it is unsuccessful. Unsuccessful open addressing technique. Open addressing unsuccessful. 1 by 1 minus alpha. Right? Probes on an average, right? When you say expected means on an average only, assuming uniform hashing. Uniform hashing means key can go anywhere. Simple uniform hashing. Key can go anywhere. That is the meaning. Some people think that uniform means, right, it is going one element here, one element here, one element here, uniformly distributing. No. Right? Uniform hashing means key can go anywhere. No partiality. No partiality. So Manohar is saying that. Hello, sir. Hi, Manohar. Hello. Hello, Manohar. Thanks for saying hello. Same to you. Same to you? Yeah, this is something related to hashing. Can you see all the points one time? If you're not clear, please refer the notes and check once. Please refer the notes, check once. Right? Perfect. Perfect. These all points, there may be a chance, these all points will come. Right? So see this one, I think I will write the number also. It may be 1, it may be 2, it may be 3, it may be 4, it is 5, it is the 6. 6 points. Okay, okay. Yeah, so I think I don't know Sophia. Yeah, Sophia. So if you have small doubt also, this is our WhatsApp number. Please ping us. We are going to help you. Right? Please ping me. Please ping us. We are going to help you. Don't worry. Don't worry. So 888-209903. Please ping us. We are going to help you. We can talk also. We can talk also. Right? Fine. Thank you. Thank you for saying. So this is the hashing. This is the hashing. Please check. Everyone, please verify. Yeah, perfect. Now let's go to next one. Let's go to next one. BFS, DFS. Thank you, Sophia. Thank you so much. Thank you. It was a blessing. It is a blessing. Your course was awesome, sir. Thank you so much. I'm really very happy for the feedback what you are giving. Now can you come here? BFS, DFS. Can you come here now? BFS. To implement BFS, we use Q. Okay, fine. So be careful. One question is guarantee. Either BFS or DFS will give 1 mark or 2 mark. Remember everyone. BFS or DFS. BFS or DFS. Or DFS. 1 mark or 2 mark is guarantee. 1 mark or 2 mark is guarantee. Right? So listen carefully. Listen carefully. And see, after this, if anyone not done BFS, DFS, please go through it. You are not done BFS, DFS, please go through it. And BFS do few problems, DFS you do few problem, or right, all the PYQs you complete. BFS, DFS, all the PYQs you can complete. Now let's see the BFS. To implement BFS, we will use Q. Okay, remember. Right, BFS we are using Q. Okay, time complexity. So I think everyone know BFS, DFS is graph traversal. You have to traverse the total graph, nothing there. Total graph without repetition. One time you have to visit. So total graph V plus E. Time complexity V plus E. And you are marking also. Are you visiting or not? When you visited, because you don't want to visit again, you are marking also. Marking purpose. Marking purpose, you are using one visited array and you are keeping all of them in the queue also. Whichever you are visiting, you are keeping in the queue also. So all OTCs you will be visited one time. So space complexity V. Next one. So it is a if you use the list, right, time complexity V plus E. If you use matrix, matrix scanning one time. Matrix scanning one time V square time. Matrix scanning one time V square time. If you go list format, so this also you have to visit. Linked list also you have to visit. Linked list purpose is E time, right? OTCS purpose V time, V plus E. So time complexity of BFT by matrix is V square, list by V plus E. Time, right? Next one, time complexity to check all adjacent of a particular node. Particular node adjacent, if you want to find out, in the case of the matrix, one row you have to check. In the case of list, it's degree. How many people are there? Those many people. Right? To find out degree of any person, in the case of the matrix, one row, which will take n time. In the case of list, right, how many people are adjacent? That much only. 3 people adjacent, 3 units time. In the case of list, less time. In the case of matrix, every time n. One row scanning n time. One row scanning n time. In the list, if no one is adjacent, right, 0 time. If 5 people are adjacent, 5 units time, something like that. Right? I think all the points are clear. Next one, applications of BFT. Right? Graph is connected or not, you can check. In the linked list, all nodes are reachable or not. or in the graph, every vertex is reachable or not, you can check. We can check if there is a cycle present or not. We can verify graph is a bipartite or not. We can verify, right? We can find single source shortest path in the undirected, right? Sorry, in the undirected unweighted graph, especially unweighted graph. We can find out single source shortest path in the unweighted graph. Most important thing is unweighted. Next one, some theorems are there. Please careful. These are very, very important. They are copied from core math. Sir, discrete maths and engineering maths bilkul nahi pada hai. Our CN 50% pada hai. Can I score above 60? So Sophia, you no need to think that much. Sophia, you no need to think that much. Can I get above 60%? Don't think like that. Whatever best possible, you try. No need to think anything about the results. The people who will think about results, right? They don't get the good results. The people who will blindly prepare, just follow some procedure, blindly do until last minute. So if you keep on doing nice work, you will get the nice rank. If you keep on thinking about rank, you don't get rank. Marks, you don't get marks. Do necessary work, you will get the good marks, good rank, and so on. Right? Whatever you are doing, do properly. Whatever you are doing, do properly, then everything is all right. So, and one more thing, this theorem, can you see this? Very, very important theorem. Please read this. Right? This also, please read it. The core man, they are the theorems. I want to explain, but it will take more time. Next one, I think this is the right explanation. Explanation is not required. These two theorems, please take care. These two theorems, please take care. This is the explanation. This is the explanation. This is the explanation. This is the explanation. Next one is the third theorem. This also, please take care. This is the fourth one. No need to write also. I can simply escape. But these may be useful. These may be useful. So this is the one more. Diameter finding. How to find out diameter of a graph. Diameter of a tree. How to find out diameter of a tree. So this one. So time complexity of this one, order of VE. Order of VE. Diameter of this one, order of VE. Right? Fine. So see this one, read this also from the core main directly I given. From the core main directly I given. I don't have time to explain here. Right? Please go through it one time. Right. Next one. Go to the DFS. Go to the DFS. We are using stack. Same. Time complexity V plus C. Space complexity order of V. Right? Applications are almost similar. One or two new applications ready. That is articulation points you can find out. Strongly connected components you can calculate. We can find strongly connected components in the given directed graph. We can find number of articulation points present in the graph. Okay. These are covered in the classroom also. One time I revised. One time I written here. Next one, here also some good theorems are there. Please take care. So parenthesis theorem, right? So please see this. Parenthesis theorem. Please take care of this. Next one. Nesting of descendants. Nesting of descendants intervals. This theorem also please take care. They are directly giving. Next one, wide path theorem. Wide path theorem. One time you have to read. If you want, you can go through the proofs also, but not required. Right? These all. So you can pause and you can read it. Right? Wide path theorem. Nesting of descendants interval. Parenthesis theorem. Please, can you go through it? These are very, very important. In the examination, they are giving directly. Please go through it. Next one. Classification of edges. You know very well. Tree edges, back edges, forward edges, cross edges. Can you go through the definitions one time? I given good examples also in the class notes. In the class notes, I given good examples also. Good examples also in the class notes I given. Next one. Right? So there is one more theorem. See, a directed graph G is acyclic if and only if in the DFS there is no back edge. So this is also one theorem. This is one more, right? A directed graph is called singly connected if this condition is satisfied. to determine that this can be done using order of V time. So you also, please can you read it? Please can you read it? Right, when you are right, just when you are watching, those people who are watching, so please, right, please read this theorem also, please see. These are useful. Without saying this, I can escape, right, from the core man. This is from core man, right? These books, one time reading is more than enough. You no need to do any research. Right? So this will be useful, see one time. Right? So this is a DFS, BFS. And one more thing is, all PYQs you do. BFS, DFS, all PYQs you do. Mostly will get the, right, 1 or 2 questions from this. BFS, DFS, 1 or 2 questions you may get. 1 or 2 questions you may get. Please let me know if anyone having any doubt. Now I think until here you done, let's go to next one. So one example I took, I verified also. Right? And one more thing, some people are asking in the DFT, what edges? DFT directed. Right? 4 types of edges. See, directed having more types of edges. More types of edges. So DFT directed, maximum edges, all possible. BFT directed, back edge, tree edge, cross edge. Undirected, here back edge and tree edge. Here tree edge and cross edge. Please verify. Right? Classroom also I explained the example. Same example, clearly I written, please check. If there are back edges, then there will be a cycle in the graph. Right? So different colors also used. What is the right? Not front edge, forward edge, back edge, cross edge, tree edge. Right? Fine. Forward, so which is also called maybe front edge, right? They written like this, but anyhow, forward edge or front edge, right? Both will be similar. Now go to the tree traversal. Everyone careful, tree traversal. So you know pre-order, post-order definitions I written. So when you say tree traversal, traversing a tree, so it's total tree, one time scanning, time complexity V. What about the space complexity? Because if you use the recursive program, tree height matters. Log V time for balanced tree, order of V time for this unbalanced tree. If we apply in-order traversal on the BST, we will get the ascending order. It's a very, very important one. Please be careful. If we apply in-order for the BST, if you apply the in-order, you will get the ascending order. It's very, very important. What is BST? Left people less than the root people less than right. At every node, this condition satisfied. Okay. If it is balanced, a BST balanced, which is called AVL tree, right? Log n. AVL tree log n. You know this very well. Next one, note. To construct the unique binary tree, we need either in-order, pre-order, or in-order, post-order. Unique binary tree means in-order compulsory. If we don't have the in-order, pre-post only there, we don't get the unique binary tree. Okay, that's perfect. Next one. When you are given pre-order in-order or post-order in-order, then the time complexity to create the whole tree is order of n square. Right? Next one. To construct a BST for the given pre-order or post-order. Only pre given but BST. Only post given but BST. So I think it will take one scan order of n. Using stack, you can do it. In the classroom we done. It is also very, very important. Next one. NRA tree. What is the pre-order, post-order, in-order? In the NRA tree, pre-order means normally root first, right? Root. Next left, next remaining. Root left over remaining. Right? So next one, what is the post-order? First, right? Post-order means root last. Now, okay, root last. First left, remaining, then root. What is the in-order? This is very, very important. Here you may be confused. What is the in-order? In-order means root is in between. Right? First left, next root, remaining. Right place remaining will come. Remember, right place remaining will come. Right? Be careful. Be careful. So remember, either a tree traversal will come or graph traversal will come. 1 or 2 questions are expected. If you are lucky, one from graph traversal, one from tree traversal. One from graph, one from tree will come, if you lucky. If you are unlucky, maybe one will come combinedly. But guarantee marks will come from this, right? If you do PYQs and if you follow this, if you follow total, whatever I written, some theorems also I given, some extra points also I given, some extra points also given. If you do this, definitely you are going to get some marks. PYQs and this one, please be careful, you will get some good marks. Right? Perfect. Yeah, if anyone find out something wrong, sir, some point is not clear, write in the comment section, we are going to help you. Write in the comment section, we are going to help you. If you feel that, sir, something I am not getting, sir, you just say to me, I am going to help you. If you say a little bit also to me, sir, this is not okay to me, I will help you. I will help you. Check. Okay, DFS also we done, right? Tomorrow as soon as we start, we start the linked list, we start the arrays, we start the, right, I think trees, right? We start the queue stack, right? Tomorrow remaining part we will do. We will do tomorrow remaining part. Tomorrow we will do remaining part. I will give the link also. I will keep the link also below where you can access. You first see the entire story one time. Entire story one time, please see. Right? Fine. Thank you. Thanks everyone.